Hello, my name is Elsa Lefebvre from UN Environment Cities Unit. Welcome to Unit 421 on Scoping and Baseline Assessment. The Danish architect Jan Gehl said, "Sustainable design is about understanding whom you design for and where they prefer to be." Establishing a baseline develops knowledge of the community and of the broader context of the site, such as the surrounding environment, land use and open space, street networks, transport and utilities connections, and social and economic conditions. This is used to identify the key issues which require to be resolved and the various elements that could act as catalysts of change. While every neighborhood needs to change to enable low-carbon lifestyles, already a great variation in the size and composition of carbon footprints exists between communities. Carbon emission assessment helps communities target their highest carbon-emitting activities and motivates those with the largest footprints to do more. The range of approaches that we will be presenting in this unit contributes to several of the Sustainable Development Goals, including SDG 3, Good Health and Well-being, SDG 11, Sustainable Cities and Communities, and SDG 13 on Climate Action. The baseline stage ensures that everyone has a consistent understanding of the factors that will impact the neighborhood. This will provide a consistent basis against which to test the impact of different development decisions. The range of assessments presented in this unit is meant to give you a good overview of the different elements that can be evaluated depending on the need. They are looking at the two pillars of a sustainable neighborhood. Green, including determining the neighborhood emissions profile and its main drivers, and thriving, encompassing a baseline for the other social, economic, and environmental drivers. This includes several analyses, such as capacity studies to assess the existing provision of education, healthcare, and housing services. Needs assessment to highlight equity, economic diversity, and affordability. Socioeconomic surveys to highlight local job opportunities. And finally, evaluation of biodiversity levels, existing green space and water bodies, and air quality. This overview unit has two parts. Part 1 focuses on scoping urban form and livability. The second part focuses on scoping in terms of carbon emission profile. In Part 1, Scoping Urban Form and Livability, we'll be looking at different types of assessments that can be undertaken. With a clear comprehension of the existing urban form, environmental and social conditions, the lead agency should agree on quality of life indicators and their baseline. Key Performance Indicators, or KPIs, allows city leaders and planners to identify performance levels at a set time to compare and monitor changes. This process should be advised by consultations with stakeholders, particularly community groups that represent future residents, workers, or visitors. The indicators should be prioritized and shortlisted, as it is more effective to focus on a smaller set of ambitious and impactful measures rather than trying to deliver lots to a lower standard. A community needs assessment can also be conducted. This is a tactical way of identifying gaps in community services. It determines the strengths and assets available. It helps planners appreciate what they have to accomplish and the steps they need to take. The assessment intends at understanding the culture and social structure of the community through demographics such as age, gender, income level, ethnicity, and more. Further, a community needs evaluation aims at assessing where people live, play, work, and gather. The analysis scrutinizes the relationship between people and places. These can include schools, senior centers, shelters, parks, religious establishments, and other infrastructure. The assessments considers the drivers of the community, what people care about, and what matters the most to them. Identifying issues is the first step to foster change. Planning and designing green and thriving neighborhoods requires to understand city form and its relationship with nature, shared urban systems, and community health and well-being issues to deliver even greater impact on equity, health, and sustainability. The assessment should comprise a clear understanding of the impact, intensity, and distribution of services needed for the community. In low-income communities in particular, it is important to find ways to gather data and identify needs. There are three main techniques for this. The first one is interviews, focus groups, and survey that allow to speak to those at ground level, to experts, and to community leaders about what they observe and experience. Second, listening and participating in people gatherings are ways to learn about local issues. And third, direct or participatory observation, visiting the community's spaces like senior centers, shelters, and schools allows to observe programs that already exist. Assessing the urban-rural linkages is another element that can be evaluated. The transect concept describes the characteristics of ecosystems and the transition from one to another. The rural to urban transect places all the elements of the built environment in order, from most rural to most urban. If all the built elements are synchronized, the place can be described as immersive, with all elements being symbiotic. As you can see on the diagram on the slide, the rural to urban transect is divided into 6 zones: natural, rural, suburban, general urban, center, and core. It is also important to assess the context. Green and thriving neighborhoods incorporate contextual features which render every place unique. The landscape and the cultural characteristics of communities should drive projects. The baseline stage ensures the whole team has a consistent understanding of these factors. A three-pronged approach can assess public space and life. Surveys of movement account for different modes. Interviews of local people acknowledge their opinion on walking and staying environments. Data analysis contributes to mapping the empirical data. The three complementary techniques have been used, for instance, in Enku, Wuhan, China, by Gail. This helped uncover the true scale of Enku's walking flows and estimate the pedestrian numbers within one of the main shopping arteries. Gail's Public Space, Public Life survey in Chongqing revealed that 150% more people were spending more time in small old streets than in the new commercial public spaces. 640% more people were spending time in traditional Chinese neighborhoods with active open facades than in streets with closed building fronts. Another element to assess is proximity. It means understanding how easily people can have access to facilities and services within a certain distance. In a 15-minute city model, everyone in every neighborhood can meet most of their everyday needs within a short walk or bike ride from home. This human-scale city model is composed of vibrant, people-friendly, complete neighborhoods connected by quality public transport and cycling infrastructure for the longer trips that residents want or need to make. Isochrone maps, shown here as central London, are a great way to see all the locations people can reach within the time limit by a mode of transport. Understanding street connectivity and accessibility can also be important. As shown in the drawing on the right, disconnected or poorly connected street patterns reduce strongly accessibility. Dense and connected street networks encourage walking, reduce the number and length of automobile trips, and conserve energy. Thus, Street network analysis should identify gaps compared to targets of connectivity, such as 100 intersections per square kilometer, although figures should be tailored to the context. This assessment helps identify actions to reconnect the street network, as shown in the 3 drawings on the slide. The provision of education, healthcare, healthy food, and housing services in the community and in neighboring areas should also be assessed. The analysis aims at identifying the most important amenities and services and how much these are provided. These also include the assessment of current biodiversity levels, green space, and water bodies and air quality. Racial and economic segregation, transportation barriers, and lack of availability factor into the ability of all community members to participate in and benefit from neighborhood amenities. The analysis of social equity, economic diversity, and affordability should evaluate the access for diverse communities. It should assess the level of mixed use, including the diversity of destinations and activity density. Key information are the type of housing and tenure and their affordability, and the job opportunities within an area and proximity to jobs by sustainable transportation modes. In Johannesburg, South Africa, for instance, the lack of land use diversity and access to health and education is critical in deprived areas, as shown by the comparisons of amenity provision per square kilometer and per inhabitant on this slide. Let's now move to our second part on scoping the carbon emissions profile. It is useful to develop an emission profile for the neighborhood, whether it is a new or an existing one. It should be done during the baseline stage using best available site data and benchmarks. A plan to update it regularly should be agreed. Using a live, easily monitored and collaborative data platform will help provide consistent reporting and insights to all stakeholders. This will require appropriate digital infrastructure supported by clear governance and data sharing protocol. This map, for example, uses multiple data to show an hourly estimate of CO2 emissions for every square kilometers between Virginia and Maine and east of Pennsylvania. Measuring neighborhoods' carbon footprint leads to understanding the main carbon emissions driver. These include land use, such as zoning, density, activity distribution, and the types of businesses. Transport infrastructures, parking, and street networks also contribute to carbon emissions. The type, form, and scale of buildings have a huge impact on energy efficiency. Green infrastructure offer opportunities for carbon sequestration. Utilities and materials are also drivers. Their analysis should evaluate the sources of energy employed and their efficiency, the management of waste, the local sourcing of materials, and the water use. Finally, regulations in the form of standards, plans, and policies at a local, metropolitan, state, and national level should be evaluated with carbon emissions. Identifying how each factor contributes to the neighborhood emissions profile allows beginning to test how changes to these factors reduce emission. For example, the Hestia project draws on multiple data sources to paint a comprehensive picture of a city's greenhouse gas metabolism. In this 3D image, each piece of land in Indianapolis is coded with a color according to the density of its carbon emissions. A carbon emissions assessment might be challenging in low-income neighborhoods due to lack of quality data, resources, and procedures. Decision makers in this context can make use of household surveys to determine building emissions, people's habits and emission profiles, land use, the use of the public and open space, etc. Business surveys allow to determine emissions connected to the supply chain of local businesses. waste production and recycling, energy production, and material sourcing. GIS-based tools can be rendered operative in low-income settings to evaluate land use evolution, transport and street networks, green infrastructure, carbon sequestration opportunities, etc. We have now reached the conclusion of this unit. Our key message is that the assessment stage ensures the whole team has a consistent understanding of the neighborhood livability and emissions profile, the needs, capacity, resources, and ambitions of the project might lead to prioritizing some types of assessments over others. Evaluating the urban form, connections, social, economic, cultural, and architectural characteristics of places through qualitative and quantitative tools allows testing the impact of actions improving livability. Especially disaggregating the drivers of carbon emission allows identifying the levers with the greater potential for carbon emission reduction. We invite you to follow the next unit for more information on the methodology to create and maintain emission profile. Thank you very much for listening.